All right, this unit and next, we only have 2 units left in the year, 2 units. I don't know if this is a congratulations. Some of you will be happy. I don't think many of you will be too sad, but you have completed all the different types of proofs there is to offer in geometry. You will not see any proofs the next 2 units unless we review one. And you have done every single construction in the geometry course. So that is done as well. Please have your compass handy from day to day, though, in case we do review one in your Regents review. Okay? But that's it. We're all done. All right, no more proofs and no more constructions. What you will see in the next 2 units, though, a lot of formulas. Okay, a lot of formulas for figures. All right, basic figures today. Let's see how many you know here. Anybody know the parallelogram one? Base times height. Yep, base times height. Anybody know the old circle? Pi d was for circumference. Pi r squared. A little Orion in the back there. R for radius length, okay. Triangle, that's pretty familiar. 1/2 base times height. Some people do base height divided by 2, whatever floats your boat. Rectangle, length times width, base times height, however you remember it. Yep. Oh, trapezoid, good luck. Has something to do with the bases because there's this pair of parallel bases, yep. You add the bases together. So base 1 plus base 2, that's what those B's mean here. There's also something else to a trapezoid that we're going to need to involve. The height. So we multiply, when you add the bases, you multiply it by its height and divide by 2 or multiply by 1/2. I like the 1/2 out there, but so 1/2 the height multiplied by the bases. And I don't expect anyone to know this one, but rhombus kite, both the same formula. 1/2 d1 times d2. Anybody want to take a guess what we're looking for as far, think about it before you just spout something out. A rhombus and a kite both have these that start with the letter D, and they are diagonal lengths, yes. And they're not congruent. They're not congruent. Anybody remember the figure where the diagonals are congruent? What quadrilateral? Rectangle and square. And a rhombus and the kite, they are not equal to each other. I will just forewarn you, these are not on any formula sheet. Okay, so what am I trying to tell you? I'm not going to give them to you. All right, they're not on any formula sheet. All good? All right, let's use them. Parallelogram first. Find the perimeter and area. All right, let's start with perimeter. You guys, perimeter, all sides added up. I got a problem, though. I was only given one side. So I know it's 23. That's all I know, one side. We are in a parallelogram, though. Opposite sides. Congruent, so I'm also going to add another 23. But what about the other 2 opposite sides? Those are not given, but they can be found. How? I'm not. 45? Yeah. What do we have? Oh, 4. How can the other 2 sides here? I gave you a little information here. How can these 2 sides be formed or found? What type of triangle did I give you? Yep, and I gave you 2 sides, so Pythag, yep. So I can do a little Pythag off to the side. 7 squared plus 24 squared equals c squared. That'll find the other side. When you find that side, let me know. Whenever you're ready there, 24, whenever you're ready. Oh, garbage. That's on me. 18 when you're ready. 25, got it. There it is. So we're looking at a perimeter of What do we have here? I'm not going to ask somebody just to add those up. 96. Haven't done it all year long until this unit. You will get it. You will get points off on a test or quiz if you don't put the units anymore, and you'll see why when we do area. So 96 feet. Next up, area. I gave you guys at the beginning of class today, area, base times height. Height is drawn to the base. Height is drawn to the base, and it's got to be perpendicular to the base. So it starts at a vertice perpendicular to the opposite side. So first, can anybody help me pick off the height in this diagram of the parallelogram? The height. 24. I know it's not a side. It's not inside the parallelogram. It doesn't need to be. As long as it starts at a vertice and is perpendicular to the opposite side. So the height here is 24. Do I have any issues there before I get to the base? The height is drawn to the base. Let me say that again. The height is always drawn to the base. So what base am I going to use here? Watch your mouth here. It's got to be an actual side of the parallelogram. The base has to be an actual side in the parallelogram. So I'm not going to use 7. I'm going to use 23. The height is drawn to the base, and the base is always a side. So as you guys crunch your numbers there, what are we looking at? 552, right? Okay, we're in area unit now. That right there is not going to cut it. Square feet. Now, I don't square the 552. It's just square units, so square feet. Okay, get used to that. Anything else there? Going. Yep, having fun already. Example 2. Uh-oh, little review time. I got a 40 in there, 45 in there. Find the area. All right, well, I think I already gave you the base. Everyone sees the height. I didn't label the height, but we'll find that in a second. But take a look, everybody. Take a look. The height is drawn to this base right here, which is how long? Well, I got to start asking people. 7. How long is the base? 17. Yep. Now the height I need your help on. Remember our rules? 45, 45, 90. What's the 9 across from? Which angle measure is the 9 across from? 45. And I'm looking for the height, which is across from the other 45. They're always the same. So that's also 9. We okay there? 45, 45. The sides across from the 45 are equal. Area of this parallelogram. Let's roll 20. Feet. Yard squared. Thank you. One job. Everyone all good? Oh, you thought you were all, I got my 45. Okay, now we go 30, 60 at you now. Yep. First of all, base here. What's the base before I get to the height? Oh, 28, you're up. How about the base? 32. Height is always drawn to the base, so that's 32. Now this is a 30, 60, 90. What's the 12 across from, ladies and gentlemen? 30, and the height across from? The 60. Ooh, what was that rule? What would I do with the side across from 30 to get to the side across from 60? Multiply it by radical. Watch your mouth. That's 45, 45, 90. Multiply it by radical 3. So this should be 12 radical 3. And it does say round to the nearest tenth. So, yeah, give me a decimal here. Oh, 27. Where are you at? You all right over there? What's the problem? Out of the rest of that group, I wouldn't be trying to confirm with anybody there. I would just go, no offense there, everybody, but questions? Take a lot to it, yeah. Ooh, boy. Ready? Find the perimeter and area of each of the shaded triangles. You got it. You got it. Let's start with the perimeter, the shaded triangle. We know how many sides already. We know all three sides of the shaded triangle. We only know how many? Two. So the perimeter is going to be 19 plus 41 plus, oh boy, I don't know. I got to find that third side. Anybody have a little, oh yeah, back there, huh? Anybody have an idea how to find that missing side I need for the perimeter? Oh, 23. Pythag, yes, Pythag. So we're going to have to do 27 squared plus 30 squared, and hey, what's that equal to? No, it's not correct. So what I'm going to do is I'm just going to leave it in square root form. We didn't put any rounding directions on there, did we? Okay. Everyone's getting the square root of 1,629? Okay. I didn't put any rounding directions on, so we'll go with write out your calculator display. Okay, if there's no rounding directions, just get in the habit of writing out your full calculator display. So we have 100 point, what do we got? 3,608,721 inches. Good, great. Everyone have a nice weekend. Good to hear. Moving on to the area. Now this is a triangle. Hey, make sure we can go. Parallelogram was base times height. Triangle 1/2 base times height. Is the base and the height of that shaded triangle already given? Height starts at a vertice perpendicular to the opposite side. I have a perpendicular line from the vertice, which is what? What's the length of it? 30. There's the height. And it's drawn to a base of what on the shaded triangle? 19, yes. That's my concern about today. We're okay picking up the height and the base. Height's always drawn to the base. And the base has to be a side on the triangle we're finding the area for. So kids, what are we looking at here? 285 square inches, yes. You and your group find the perimeter and the area of the shaded triangle in part B. Write out the full calculator display. There's no rounding directions here. Write out the full calculator display. Have a plan, please, between you and your group if you're doing it with your group. Have a plan. Have a plan. This one's a little involved, this one. Okay, with the perimeter, 71.7413.566 centimeters. That's what I found for the sides by doing Pythag, the square root of 133 and the square root of 974. Anybody want to go over where those numbers came from? Let me know. Pythag, again, here you go. 6 squared. And here's where you make, this is what where did I get 6? Oh, yeah, 6 squared plus, hey, take a look over here. That's the B value. So plus B squared equals 13 squared. So hopefully you didn't do 6 squared plus 13 squared. Okay, because that side is not the hypotenuse. And that's where I got the square root of 133. And then I did square root of 133 squared plus 29 squared equals C squared for the hypotenuse of the shaded region. Questions there? Okay, real quickly. Base times height. What type of triangle are you working with as far as the shaded region goes? It's a right triangle. Anybody remember where the base and the height were? Another name for the base and the height of any right triangle. Legs. They're the two legs. Okay, so 29 and the square root of 133, which you found before. And that ended up being 167.2221576 centimeters squared. All right. Right triangle, base and height of the legs. Questions before we get to DeAndre? All right, let's do it. He's going to throw some good old mulch down on his triangular garden. Anyway, one bag covers 12 square feet. How many bags is he going to need? Ready? Covers how many? 12 square feet. Automatically, because I see the square feet, this is asking me for area of this triangle. All right, I see the square feet area of the triangle. All right, I think we can find that. 1/2 base times height. Height is always drawn to the base, perpendicular to it. What is the base of his garden right here that we're going to use? Oh, it's 22. What's its base we're going to use? This part's not part of the garden, though. Just 7. It's got to be a side in the triangle. And then if 7's my base, what height is drawn to it? 9. 9. Look at that. Perfect timing. So we have an area of 31.5 square feet, correct? Okay. Now here's, we got to get used to this unit and next unit. One bag covers 12 square feet. The issue is always, do I multiply? Do I divide? I don't know. Don't guess. Okay, don't guess. We have 31.5 square feet. Every one bag covers 12 square feet. How are you going to find how many bags we need? Divide it. Yes. Number of bags. I'm going to take that 31.5 square feet, divide it by 12. And now here's where the common sense radar needs to go off. All right. Sorry, Colin. 31.5 divided by 12. I get 2.625. You cannot go to Lowe's or Home Depot and walk in and say, can I have 2.625 bags of mulch? It's not going to work. You're going to get laughed at. All right. More of an embarrassment than some of you already are. All right. Too harsh? Too harsh, Ellen? Get over it. Okay. So how many bags am I going to need to do the job? 3 bags. Okay, there's not going to be any directions that say round to the nearest whole bag. No, we're going to have to know I can't walk into a place and say can I get 2.625 bags? What's that? Doubtful. Doubtful. Other questions here? All right, well, he's got more stuff. He's got more to do here. He wants to put paving stones around his garden. Beautiful. This is going to look unbelievable. 1 paving stone's a 4-inch border. How many stones is he going to need to buy? Not talking area anymore, am I? We're talking perimeter if we're going to do the border of the garden. And look, this is pretty easy, right? I gave you the 23, gave you the 15, gave you the 7. You are on your way. And you're like, I got 45. I got 45 feet. But we got a problem because you can't pull this on me now. Oh, divided by 4. Here we go. Second thing you got to be aware of this unit and next. Units are going to change within the same problem. And we got to be aware of it. All right? Some of you are still like, what do you mean? Well, that's 45 what in units? Feet, but each stone covers 4 inches. All right, let's get ready for that. Got to be able to focus and figure that one out. You will see a change mid-problem. So this is 45 feet. How do you want to change it into inches? Multiply it by 12. So the perimeter in inches will be 540. Please, I'm going to beg you, be aware, read it carefully. All right, now what can I do to find the number of stones? I can take 540, divide it by 4 inches for every stone. How many stones is he going to need? 135 stones. Everyone all good on DeAndre and the mulch and the stoning? Good? Okay, please let me know if you've heard of this concept in, I don't know, earth science, one of the sciences, they may talk about it. Population density. Yes, no? Okay, so we're going to play a little game quick before we get into it. Population density. It's the population of the area divided by the actual land area. So for instance, if we take this classroom right now, pretty small space, everyone agrees? Pretty small space. We pack it with a lot of people, that's going to have a high population density. Versus maybe we go in the auditorium and I put a few kids in there. Even though the auditorium's a big space, doesn't matter because I put a couple kids in there that has a low population density. All right, so that I know you are picking this concept up. Anybody want to try to guess the state that has the highest population density? So we're going to try to think about, don't think big states, not necessarily the biggest state I'm looking for. I'm looking for a decent sized state with a ton of people in there. That's what I'm looking for right now. Decent size, and then maybe who has the lowest population density? State that has the lowest population density. Okay, guesses before we reveal. What do you think, Maggie? I got New Jersey. Any others? States? New York? New York City's pretty packed, so yep. Delaware, pretty small state. Well, I don't know how many people are in it, but Maryland? Orion? Mass. So you guys are going a lot of New England states here. All right, let's find out. Highest state population density. New Jersey, number 1. Rhode Island, number 2. And then the lowest, Alaska. Alaska, the lowest. Okay, Wyoming, second to last. So there you go. Delaware's number 6, New York number 7, Maryland 5. Yep. So there you go. Texas 26. Yep. Montana, Dakota, both Dakotas low. Idaho. Yep. All right. So there you go. So we okay on the concept of population density. Okay. So instead of doing states, let's go to the 5 boroughs in New York City. And let's find which one has the highest and which one has the lowest population density. Okay, so if I take Brooklyn right now, I'll do the first one with you here. If I take Brooklyn, you take the population and you divide it by the land area. That's how I find the population density. What do we find? Who has the highest? Small area, a lot of people. And how about the lowest? Big area, but not too many people over in the island, huh? We okay on finding the population density? Population divided by the area of the land. Questions? Okay, how do I apply this to actual shapes we're talking about? As I think I put it at the top of your page. Yes, example 2 came from a Regents exam. All right, so this will somehow pop up on the Regents exam in a couple months. Which Petri dish has the greatest population density? All right, so let's take Petri dish A first. Formula says population, so what's the number of bacteria in Petri dish A? 40,000. And now I need to divide that by the area, which is not given. But we had a formula at the beginning of class, area of a circle, pi r squared. So off to the side, I'm going to have to find the area of Petri dish A and B when I get to it. What's the 51 there? That's my diameter. I got to cut it in half, so the radius will end up being 25.5 squared. If you want to just plug that in right to the formula, you can, or plug the whole decimal in. We're not ready to really round yet. 25.5 squared. And we're going to compare that to Petri dish B, which has 72,000 bacteria. What's the radius for Petri dish B? 75 divided by 2, also known as 37.5 pi times 37.5 squared. And then let's compare the two. Which one has the greater population density? $17 when you're ready. Who has the higher one? How'd you get B? What are your population densities for A and B? Yep. And then what about for B? So you're just guessing. Again, you guys that have them, use the fraction template here. Or parentheses in the denominator. $16 point. Okay, so which one has the higher one then? A. Yep. Packet. Oh, whoa. You got packet and book, and in the book, you got a graph one tonight. Did we provide graph paper at the end of your packet? No? Okay. Sorry on that one. If you need to take some, there's some over on the shelf. You're going to be required to graph one tonight. It's not optional. Go over on the shelf, take the graph paper.